Hello everyone, thank you for joining today's session. Today we will discuss how to increase efficiency of robotics application using time-of-flight cameras. I'm Alexis Tessier, Product Marketing Manager at Lucid, and we are very pleased to join this tech summit today to introduce the latest in our Helios time-of-flight camera series, the Helios 2 Plus. This new camera brings two new key features that we believe will be of great help in robotics application: HDR imaging for high dynamic range scenes and high-speed mode for moving scenes. Before we start with this presentation, I will just turn off the video to let you see the slides in full screen. To begin with, a few words about Lucid. Lucid is a Canadian company with over 75 employees as of today and offices in Canada, Japan, China, Taiwan, and Germany. Lucid has 5 main camera series, all of them based on the Ethernet interface covering from 1 gigabit to 5 gigabit and 10 gigabit in different flavor. We have, as of today, over 85 unique camera models. All of them are designed and manufactured in Canada. Lucid was the first company to introduce a time-of-flight camera based on Sony depth and sensor in 2019 with the launch of the Helios time-of-flight series. Before that, prototype was announced and demonstrated at Vision 2018 in Stuttgart. Since we launched the Helios camera, we have learned a lot about our customer application, about their challenges, and we improved tremendously the capabilities of our ISP for processing the data coming out of the depth and sensor. Last year, we launched the Helios 2 camera that had a variety of functions, making the point cloud of higher quality and being able to cope with a variety of scene and configuration, and also leveraging the factory tough housing that we have designed, including these IP67 capabilities. Soon after, we launched a kit combining a Triton RGB camera together with the Helios 2 and being able to combine the visible RGB image together with the point cloud. And just a few weeks ago, we have announced the Helios 2 Plus camera series that is very similar to the Helios 2. It's basically mechanically the same, but it adds these two new key features for HDR imaging and high-speed mode. So what is Helios? Helios is an industrial 3D camera designed for high-quality point clouds in indoor use. We use the Sony IMX556 depth and sensor, which together with our processing in the ISP achieves an accuracy of 4 millimeters and a precision of 0.6 millimeters at a distance of roughly 1 meter. The resolution of the point cloud is 640 by 480 pixels, and the working range goes from 0.3 meter all the way to 8.3 meters. The optics has been designed to maximize light transmission and reduce scattering and reflection. In addition, Helios includes an ambient light filters that can be used to avoid perturbation with the ambient light. In addition to this, we use 850 nanometer V-scale LEDs that were selected as this wavelengths to provide the highest quantum efficiency in near-infrared with the depth and sensor. Helios 2 is what we call the factory tough camera. It's built for 24/7 operation in challenging industrial environments. This includes shock and vibration certification, EMC industrial immunity, dust-proof and water resistance with IP67 rating, and single cable operation all the way to 100-meter distance with power over Ethernet. And it includes secure connection with M12 connector for data and power and M8 connector for GPIOs. The camera is quite compact, 60 by 60 by 75 millimeter, with excellent thermal management, making it easy to use and easy to integrate for tough industrial environments. Leveraging our experience that we gained with the Helios first generation products, we revised the ISP that we use for processing the point clouds. We still use the same IMX sensor, as IMX556 depth and sensor as with the first generation, but the ISP has been refined and provide some key features that help increase the quality of the data. Image accumulation that is able to stack depth frame together to improve the quality of the point clouds. Exposure and gain control, making it usable in different lighting conditions and with different object reflectivities. And confidence threshold and spatial filtering to reduce false positive and artifacts. In addition, we can combine it with RGB data from Triton RGB cameras. And lastly, we have a communication channel that allows up to 5 Helios 2 cameras to work together in the same scene. Time of flight is an active scanning technology. The camera emits light, and if we did not have this communication channel, it would be impossible to have multiple cameras working together in the same system. Now for the Helios 2 Plus. Taking it one step further, still leveraging the same factory tough housing and IMX depth sense sensor, we have refined the ISP design to bring those two new features, high dynamic range, that combine multiple exposure time in the phase domain. It's not combining point clouds after the fact, it's before the point cloud is created that multiple exposure are combined to be able to cope with scene including both high and low reflectivity objects and overall a wide dynamic range. And for moving applications where either the camera is mounted on a moving vehicle, like an autonomous system, or when the camera is scanning a moving object, like a pallet or a box on the conveyor belt, the high-speed mode. The high-speed mode increased the camera frame rate to 110 frames per second and avoid ghosting and deformation with moving objects. All other features are the same as the original Helios 2, and all processing is realized in camera with no additional burden on the backend system. So, how it's used. Here we have some example of our customers' application using the Helios cameras. The first one is a bin picking application where the customer was looking for a cost-effective 3D solution with, that was compact and lightweight. They selected the Helios and mounted it close to the robot to realize this bin picking application. The one on the right-hand side is another robotic application in cheese production and ripening facilities where stack of cheese needs to be rotated at given interval to continue with their ripening and aging. This application requires several cameras to be mounted directly on the stacker and being able to cope with very complex scenes, including shiny objects like those racks that can be of different finish or different texture. And overall, they selected the Helios camera compared to other 3D scanning techniques because of its combination of reliability of operation, lightweight, and its capability to work in parallel with no perturbation. We have two cameras using the communication channel here. Very new application from another customer in the logistics industry. This is a palletizing application where a stack of empty pallets arrives and needs to be picked individually and placed on a conveyor belt. The camera is mounted inside the picker. And those pallets have different shape. They can be eventually damaged or they can be painted. And overall, the manufacturing tolerance for the pallets are very wide. So this customer leveraged one of the unique capabilities of time-of-flight technology. It's in addition to providing a depth map or point clouds, combining it with a standard black and white image, an intensity image which is the near-infrared image captured by the depth sensor. Leveraging those two data sources, they developed their own deep learning and classification models and were able to accurately identify and pick the first palette independently of the palette type and configurations. Initially, this customer tested different 3D scanning technology like LiDAR, but they were not satisfied by the size and cost of the solution, and this is where the Helios was selected. And some other example of use cases, not directly in the robotic industries, or not in the industrial robotics industry. This is tomato measurement and picking, where the Helios needs to detect the tomato. It's used for dimensioning, for measuring the size. Here you can see that we measure 63 millimeter, which is very close to the actual size of the tomato. And the next step is to locate the position of the leaf for cutting and picking the tomatoes. Here we have another customer application for luggage scanning in an airport. More and more, airport needs to be automated and self-check-in needs to be realized. So in this case, the customer will deposit their luggage on the conveyor belt and an Helios camera will scan it and use it for measurement. And lastly, some application that we forecast with the Helios 2 Plus and that we are very excited about is the automotive industry. A full car assembly is notoriously difficult to scan because there is variety of material, texture, finish, color, both high and low reflectivities. Here we have some example using the new HDR mode. You can see in the first one, focusing on the tire of the car, the quality of the point cloud that can be achieved using the new HDR mode. And looking at a few other parts of the car, again, very difficult object to scan with usually time-of-flight technology or other scanning technology. And in this case, with the new HDR mode, we get very high quality of point cloud with very few adjustments. We just use the camera and enable the HDR mode. The parameterization is minimal. So how it's done? The first step to get good quality of point cloud is to select the operating mode for the camera. In total, 6 operating modes are prepared, covering different depth range. Starting with the Helios 2, the depth range is no longer locked to the front of the camera and can be adjusted all the way from 0.3 meter all the way to 8.3 meters. How the operating mode is selected, this will depend on the scene and the object size, depth, and camera distance. And the trade-off can be decided depending on the expected accuracy and precision and overall scene parameters. Once the operating mode is selected, the next step is to find the right exposure adjustment. Depending on the scene and the reflectivities of the objects, they can be both specular highlight with shiny metallic surface typically and darker parts. The exposure time adjustments need to be carefully considered. The Helios provide 3 exposure settings. It's not like a typical machine vision cameras where you can get a slider and adjust the exposure time more or less continuously, because any exposure time needs to be carefully calibrated at factory side. We selected 3 main exposure time: the 1000 microseconds, which is the default one. But we can see in this case that this object was not reproduced correctly using 1000 microseconds. Now we switch to 250 microseconds, and we can see that this metal strut can be imaged accurately. We can look back at 1000 microseconds and see the effect. One more setting that can be used to improve the 3D image quality is the image accumulation mode. By combining multiple frames in the depth domain, in the phase domain, so we are not combining point cloud, we are combining measurement or subframe in the phase domain, we can increase the quality of the resulting point cloud. Here we see the comparison between the standard operation at 30 frames per second and the accumulation of 8 frames, in this case, dropping the frame rate to 3.75 frames per second. A closer look at the quality difference between these two modes. So that was with the Helios 2, but we wanted to get a bit further with the Helios 2 Plus and combine those exposure time management together with frame accumulation. That's what we realized with the high dynamic range mode. Here we have a typical scene with different objects, different boxes, both dark objects like those cables with low reflectivities that usually will require longer exposure, and other objects with higher reflectivity like those labels on the boxes, those white labels on the box. If we look at the different exposure time and what we can see from this scene, using the shortest exposure time, 62.5 microseconds, the boxes are clearly defined, but the cables are basically not visible. Only this one can be barely noticed. The other one are not visible. Once we increase the exposure time to 250 microseconds, we start getting a better picture of the scene, but as you can see here, this white label is already saturating, resulting in this hole in the point cloud. It's been filtered out. And if we go all the way to 1000 microseconds, in this case, the cables are very clearly defined and could typically be picked by a robot accurately, but the boxes are more or less completely saturated and just not scanned correctly anymore. Combining this frame accumulation mode together with this exposure time management, we are able to get an HDR image that shows both the low reflectivity objects, the cables, and the high reflectivity objects, the box and label, together in a single frame. Let's have a closer look at the different exposure time compared to the HDR mode. And finally, the last new features we have with the Helios 2 Plus, which is kind of the opposite of the HDR mode. Instead of accumulating frame, we scan much faster from a single frame perspective compared to the standard mode running at 30 frames per second and using 4 phase measurement to create a point cloud. The high-speed mode is able to get a usable point cloud with a single phase measurement. Typical use case for this will be scanning object on a conveyor belt. Here we have a moving box. Left-hand side is the standard mode at 30 frames per second. Right-hand side is the new high-speed mode. So there is a trade-off. It's more noisy. But we can see that the box is clearly defined. There is no ghosting or deformation or after image. And if we look closely on the left-hand side, those edge and valleys are not correct. And it can't really be used for dimensioning. On the right-hand side, using the new high-speed mode, the box, even though they are more noisy, they are clearly defined. Some more example with the high-speed mode. Here you can see the basketball, especially when it's bouncing. there's ghosting and deformation. Looking at the high-speed mode, the ball retains its shape and is not deformed or ghosted. Once we zoom out, it's even more visible. Left-hand side is the standard mode at 30 frames per second. Right-hand side is the high-speed mode at 110 frames per second, where we can clearly see the ball is scanned with no deformation or ghosting. So that's it for the Helios 2 Plus. And overall, standard question, we have a Q&A session at the end, but this question always pop up, so we'd like to answer right away. How small can you go with time of flight? There is not a single answer. This will depend on your scene, on the objects, on the reflectivities, and on the surrounding surface. If you have lots of small objects with shiny surface, they might create multipath, where the lights are reflected from one object to another. In this case, in this specific instance, we have objects roughly 2 to 3 centimeters, and we believe we can achieve good enough accuracy for this purpose. But this will depend on the actual scene. And lastly, a few words on the software interface for the Helios. So all processing is realized in camera, and the output is a depth map that can be combined with illumination and confidence values. But to control the camera, to visualize the image, we have the Lucid Arena SDK. That is a comprehensive toolkit supporting several platforms, Windows and Linux, x86 and ARM platform, multiple languages, C, C++, .NET, C#, and Python, and various pixel formats. We have an easy-to-use GUI providing both 2D and 3D view, and that lets our user evaluate and prototype their application very easily. Together with the SDK, we have a large library of sample program and example that help user get up to speed quickly, including example of a GUI application with Qt or MFC. And it's performance focused. The driver is optimized for reliable transmission and low CPU usage. In addition, the Helios camera series is interfaced with many third-party software solutions, which you have some of them listed on this slide. That's it for our presentation today. If you have any question, we have a short Q&A session starting now, or otherwise feel free to reach out to one of our local sales office in our headquarters in Canada, Europe, Asia Pacific, or Greater China. Thank you very much for your time today.